Newton's second law of motion. The force acting on an object is equal to the mass of that object times its acceleration. F equals ma. Twirly Socrates, do you agree that if m and a are singular, F should also be singular? It is Joe's mass times Joe's acceleration equals Joe's force. It is not Joe's mass times Joe's acceleration equals their force, or their force equals Joe's mass times Joe's acceleration.
F equals ma. F represents the vector sum of forces applied to one object. M is the mass of that object. A is the acceleration of that object.
I agree with Twirly Socrates.
Vector sum of forces applied to one object. That appears to be another way of saying their force. Let's apply that to an equally matched arm wrestle. That asserts if an arm is not accelerating, then there are no forces acting on the arm. Ben, do you agree that x times 0 equals 0?
Yes.
50 pounds of force plus 50 pounds of force equals 100 pounds of pressure, right? With 0 acceleration.
You said, that asserts if the object is not accelerating then there are no forces acting on the object. That is incorrect. If it is not accelerating there is no net force acting on the object. It is possible for 1,000 different forces to add up to a net force of 0. If two kids pull equally on a rope, the forces exist, but the rope does not accelerate.
Now you are bringing in negative forces like Ben did in a previous discussion, saying 25 pounds plus a negative 25 pounds equals 0 pounds.
Is that a problem? The negative sign only means that the force is applied in the opposite direction.
0 represents no force acting on it, which clearly isn't the case.
How would you describe a scenario where two kids pull equally on a rope? The forces exist, but the rope is not moving.
In your rope example, I acknowledge that there are forces present. I don't pretend like they are not there and describe it the exact same way as a rope that is not being pulled on.
That is correct. A rope sitting on the ground has a net force of 0. In the tug-o-war scenario, there are forces on the rope. If the kids pull equally hard, they add up to a net force of 0 and the rope does not move.
Okay, I'll ask you what I asked Ben. Do you agree that the floor is not subtracting any force exerted by the dumbbell?
No. To get a net force of 0 on the dumbbell, we have gravity pulling down, and the floor pushing up on the dumbbell. The two forces cancel each other out, or subtract, as you put it.
Do you agree that the floor does not change how much the dumbbell weighs?
Yes.
Yes.
To subtract or cancel the weight of the dumbbell, you would have to change how much the dumbbell weighs. And you agree that the weight of the dumbbell does not change. So with your statement here, you appear to be contradicting yourself.
I have $0. I make $100. My net profit is $100. I spend $100. My net profit is now $0. Do we agree that I still made $100?
Yes. $100 was also clearly taken away.
I have a net force of 0 acting on me in the horizontal direction. A force of 100 newtons to the right is applied to me. My net force is 100 newtons. A force of 100 newtons now also pushes, or pulls, doesn't matter in this case, on me to the left. My net force is now 0 newtons. Do we agree that the force pushing to the right still exists?
We agree that the force pushing to the right still exists so long as it wasn't a temporary push that was taken away.
Do we agree this is different than the diagram on the left?
Yes.
Do we agree that using vectors, the way we distinguish these two cases, is by having forces in opposite directions have opposite signs, plus or minus?
You said we distinguish. If that includes me, then I don't distinguish it that way and disagree. If we means you and others, then yes, I agree that is how you distinguish the difference. I distinguish things by drawing things differently. 100 pounds of force plus 100 pounds of force equals 200 pounds of pressure.
That's a diagram. You are not notating the vectors using vector notation.
I agree. I chose to show it this way to portray the information more accurately.
Do you agree that you are unable to distinguish the two cases above by vector alone if there is no diagram?
I disagree. 100 pounds of force to the right plus 100 pounds of force to the left equals 200 pounds of pressure. Information relayed and no diagram necessary. Here is Joe. He is being pushed on by Jill and Jane. Now let's view this under your terms of MA equals F. Joe's mass times Joe's acceleration equals the combined forces acting on Joe. In this case, Joe is not accelerating. So that means the combined forces acting upon Joe would have to be 0, if the above is true. Twirly Socrates, do you agree that the vector sum of forces acting upon Joe is not 0?
No. The net force on Joe is 0. Forces are mathematically represented as geometric vectors, and when you add two equal and opposite vectors, they sum to 0. Jill and Jane's forces are non-zero and sum to 0.
Jill and Jane in this case are not pushing on Joe with equal amounts of force.
What? You're making up an impossible scenario. If Joe's acceleration is 0, it's not possible for Jill and Jane to push with unequal force.
This isn't impossible at all. It is only impossible by Newton's standards. Jill can barely be touching him at all, while Jane is over there leaning on him, applying a bunch of force, but not enough to overcome Joe's inertia and cause him to move because Joe is a big guy. Do you agree that Jill is not taking any force away from Joe or Jane in this scenario?
To answer your question, Jill's force opposes that of Jane's. When we compute the net force on Joe, some subtraction will occur.
Do you agree that subtract means take away?
To subtract means take away. Do we really need this? Isn't that obvious?
If you are subtracting forces but don't claim Jill is taking any force away from Jane, then yes, we need this. You claimed some subtraction will occur. Do you agree that it is not an equal and opposite amount?
If Jane is pushing harder than Jill, those forces are not equal and opposite.
Do you now agree that since there are unequal and opposite forces acting on Joe, that the net force acting on Joe is not 0?
No. If Joe's acceleration is 0, his net force must be 0. It is an axiom of Newton physics, the second law. In your example, Jill and Jane's forces are unequal. Therefore, there must be at minimum a third force acting on Joe. In a real-world scenario, Joe's body is also interacting with the ground via friction. The net, horizontal, forces in this situation would look something like this: F_net_Joe equals F_Jane, minus F_Jill, minus F_friction equals M_Joe *0 equals 0, so F_Jane and F_Jill are opposite, but not equal. However, in this analysis, F_Jane is equal and opposite to the combination of F_Jill plus F_friction. Note that I've not included Joe's weight or the normal force of the ground in the above analysis. I can do this because horizontal and vertical motion can be treated independently.
Are you trying to say a third force is coming in and subtracting from both Jill and Jane's forces, making them equate to nothing?
Yes, that must be happening if Jill and Jane's forces are unequal, and the acceleration is 0, a third force at minimum.
Do you agree? The third force of gravity is not taking away any of the force that Jill or Jane is exerting on Joe, and that he still feels the pressure from Jill and Jane pushing on him?
Agreed. Newton's laws give each axis an independent treatment. The force of gravity does not affect the balance of the net horizontal forces. There is a caveat, which is that frictional forces are proportional to normal forces, which, in this situation, is proportional to gravity, but the force of gravity itself does not directly contribute to the net horizontal force. Friction is subtracting from Jill and Jane to make their forces amount to 0.
You agreed that Joe still feels the force from Jill and Jane as pressure. So do you now agree that their combined force is not 0?
All three forces are non-zero. Joe will feel all three forces. The sum of those three forces, the net force, is 0. Please keep in mind that the net force doesn't tell you much about what Joe feels. It's possible for his net force to be 0 while his internal stress is very large. If Jane and Jill push sufficiently hard, his internal stress could become large enough to inflict pain, or even break Joe.
Despite pointing out his contradictions left and right on this matter, I still can't seem to change his mind. If there is something you'd like to add to this conversation, please come visit us on our debate board. There is a link in this video's description.